So Abhijit, my question to you is, what is the confidence interval? Any clue?
So basically,
Hello. Hello. Abhijit, what is the confidence interval? Any clue? Abhijit, can you hear my voice?
hear your voice, sir.
Yeah. Hello.
Well,
Yeah. Can you say me what is confidence interval?
can you hear me, sir?
I'm really not understanding what you're saying. A confidence interval is a range of values we are fairly sure our true value lies in. So here with true value, I mean to say I'm looking for some parameter. Okay, like mu. Mu is a parameter. It is a parameter of what? Average, correct? It says average of a population, correct or wrong? Hello.
Yes, sir. I can hear
Yeah,
you
so
well.
it tells you about the average of some population data, whatever you have taken. So confidence interval is something but the range of values between which your mean lies, or range of values we are fairly sure. Here with the fairly sure we mean 95% we are sure, let's say. That's the reason why we say na 95% we are confident that our mean lies in this particular range. So the range in which your parameter lies, your point estimate lies. So I'm using one more word, point estimate. Point estimate is also what? Is nothing but your mean, correct? Point estimate is something, point estimate is for population. If you have population mean, sorry, sample mean, sorry, point estimate is for sample. If you have sample mean, can you find out the population mean? Yes, you can definitely find out the population mean, correct?
Yes.
What is a point estimate? If I have to elaborate properly for this. So I'm writing a point here. Please understand. So even this parameter also I'm writing some points here. Parameter. See, if these terms are very clear to you now, the coming chapters are going to be very easy for you. Parameter. A parameter is a number describing a whole population. Example, population mean. So we cannot see it represents that population because something about that population this is saying, correct?
Oh, yes.
This is a parameter. Someone tells you what is statistic. So statistic, you have heard about a word called sample statistic, correct? So what is a statistic? It is a number describing a sample. Example, sample mean. Okay, some more points we'll discuss. Point estimate. So is a single value estimate of a parameter. So sample mean is an estimate of population mean. That means it can approximately tell you about population mean, correct?
Yeah.
Okay, and what is interval estimate? The one which we are studying right now, confidence interval. Okay, so this confidence interval gives you what? It gives you range of values where the parameter is expected to lie. I'll give you a formula also of this. It is a range of values where the parameter where the parameter is expected to lie. So confidence interval is the most like some very good example of interval estimate. Okay. Now we can go for the like detailed explanation of this confidence interval. Okay, please properly understand this one. So I'll draw a population a confidence interval in front of you. Let's say this is these are range of values. Here the mean is 4, 5, 6, 7, 8, 3, 2, 1, 0, minus 1. So now 4 plus or minus 2 means what? 4 plus 2 is 6, 4 minus 2 is 2. So I'm just taking the values here to here. Okay. I'm taking values from here to here. 4 plus or minus 2. So this is my confidence interval. This are the range of values where I can clearly say my mean lies. Okay. Correct? Understood? Abhijit? So let's see the formula of this, and we'll do a practical, we'll do a question also on this, and I'll give you some Z values which you need to note down. Okay. Now, so confidence interval is equal to mean plus mean of your estimate. Okay. That means sample. Mean plus or minus the variation. Mean of estimate or sample plus or minus variation in that estimate. Easy to understand. And generally the formula of confidence interval, if I have to give you, I'll give it here. So confidence interval is equal to x bar plus or minus z into s by root n. This particular total factor is nothing but shows the variation. Correct? What is this z here, Abhijit?
So normalizing value.
Z is nothing but it's called Z value or Z score. It tells how many standard deviations you are like the point where you are here. For example, this is your mean now. Suppose you are here. So your Z value tells you how many standard deviations you are away from the mean. Correct? If I get Z score of 3, that means 3 standard deviations away from the mean. Understood? See, I am simply explaining the things here. Okay. Just make a note of all these things. So we'll take a small data and we'll try to find out the confidence interval right now. Okay, Abhijit? A practical question we'll do.
Yeah, we can do it.
Shall I explain that?
Yes. Yeah, we can move ahead, no? Are we waiting for something?
Yeah, tell me, Abhijit, you are saying something?
Yeah, please move ahead is what I'm trying to say. Go ahead.
Oh, like there are some 40 people, okay, we are taking and we want to find out the height. We are measuring the height of 40 randomly chosen men, okay, and height of 40 randomly chosen men, and the mean what we got is mean height is 175 centimeters, correct? And the standard deviation also is 20 centimeters, let's say. 95% we are confident. That means 95 out of 100 times. Now we are going to find out the confidence interval, Abhijit. That means 95 out of the 100 times we are confirmed that our mean will lie in that range. So I'm drawing the diagram also in front of you. 165, 170, 75, 180, 185. So here is our mean and standard deviation of 20 centimeters, I told you. Okay. So my range would be between 168.8. This, how am I getting this one? I'll prove this one for you right now. And here 181.2. So 175 plus or minus 6.2. Now the question is, from where you got this 6.2? See, standard deviation is not something which is a final thing for us. We want to know the variation. How to find out the variation? Z into, what is the formula I gave you about variation? S by root n. So standard deviation is what is given. Z score we need to see for what confidence interval we are looking. We will be having some range of values. Okay. So I'm writing those values here in front of you in the table. Just make a note of this. Confidence interval Z. 80% confidence interval 1.282. See, for us, three things are important. I'll write only those things now. 90%, 95%. Generally, we see for these three percentages only, correct? 1.645, 1.960, 2.576. See, no need to go for finding out this one and all. These are standard values. What are this? Hello?
Yeah, standard values.
We will find out also, don't worry. We will see in the coming question. Okay. So these are the values. Now, we will find out the confidence interval here. 175 is your mean, plus or minus. For 95% confidence interval, we have to take what? 1.960, okay, into standard deviation is 20, divided by how many men we took? 40, root 40. Okay, can you calculate this one? You will get the entire thing as 175 plus or minus 6.2. Okay, Abhijit? Hello?
Yeah, I said okay.
So your confidence interval is 175 plus 6.2 is 181.2. 175 minus 6.2 is 168.8. And between these two values, exactly your 95% confident or 95 out of 100 times, you know that your mean is going to lie.
Okay.
Okay.
Yes.
Once done, tell me, Abhijit.
Just 2 minutes. Yeah, we can do. Follow, we can go on.
Sorry?
Yeah, we can do it.
I'm not getting your voice, Abhijit.
I'm not sure what's happening. So.
No. See, your voice is very low pitched today. I don't know. So what you're saying is I'm not hearing that. Okay. Shall we move forward? Okay.
Yes.
This is a normal distribution. See, this is your expected value. What is mean? This entire area covers the 68% of the area of this normal distribution curve. That is, you are one standard deviation away from the mean. Okay. And this, when you are two standard deviations away from the mean, 95% of the data is covered. Okay. And when you'll be three standard deviations away from the mean, almost the entire area you will be covering. Okay, that's what they are saying. And this is, suppose if I get this, like your this thing, this expected value or mean lies in this interval, correct?
Yeah.
You're 95% confident. Now, see, these are the values, the Z score, what we discussed right now. For 90% confidence interval, mean plus 1.65 S, correct? Yes. And this S by root N, it should come actually. And here also X plus mean plus 1.96 S. S means here S by root N, error. You will be seeing that. And for 99% it is 2.58. Okay. Now, can you just like go for this question, Abhijit? Can you find out this one? Hello.
Yeah, I'll solve it.
Okay. Okay. Don't understand in this. They have not given the number of observations. The average return of mutual fund here, it is just one fund. So root n doesn't make sense for us, correct? If they give you numbers, then you have to take root n as well, correct or wrong?
Just wait, sir. I'll finish it.
Yeah. So 95% confidence interval already gave you the values even. You can find out the confidence interval. This is mean standard deviation. So your what returns lie between this range. Okay. You're 95% confident. Finished.
Yeah, okay. Yeah, we can move on.
Okay, we'll move. Now the next concept which is coming to you is standardize a random variable. So why there is a need to standardize, Abhijit?
For comparisons.
Yeah, see, if you have a very big data, okay, let's say if I make this, if I see this standard normal distribution, just wait just a second, Abhijit. Yes, hello. Yes, let's begin. See, standard normal distribution. So what is the speciality of this? A standard normal distribution is a type of normal distribution with mean what? How much, Abhijit? With mean 0 and
Standard distribution.
standard deviation 1. Okay. So normal distribution will have a center at 0 and the intervals increase by 1. Fine. See, the mean and standard deviation in a normal distribution is not fixed. They can take on any value. See, this is what we are just standardizing to scale. That means to put things in a particular scale. We made this. We may have any data and that data may have any mean, okay, and any standard deviation. But if you want to scale them, if you want to standardize them, this is the way you should do. For example, if I draw a diagram in front of you, so this is a 0, 1, 2, 3, -1, -2, -3, correct? And I make a particular normal distribution. This is your mean, but my data was 50, 55, 60, 45, 40. This was my actual data. But this data, I just standardized it by kind of denoting 50 as 0, correct?
Yes.
My mean was 50, but my mean now I'm representing with this term. My standard deviation was 1. So here you see the difference of 5. So every 5 standard deviations here mean 1 standard deviation here, correct? So I can just make the thing simpler and I can find out the answer for my questions, correct? This is the way you do. That means you're just scaling that. You want to write this?
Yeah, I just noted it down as we speak.
Okay.
Yeah, we can go ahead.
And the z-score formula is data point. I'll just give a separate note because next question you are going to do. Okay. So once done, you can tell me. Inform me when done, Abhijit.
Yeah, I'm just finishing. Yeah, it's done.
Okay. Now next, because you are going to do the question, I'm going to give you a complete detailed analysis of this. This z-score, that means this is used to tell us how far from the mean the data point is. That means the point you are looking for. Okay. And you can calculate the z-score with mean and standard deviation. That is what these two are required. Okay. Also called as z-score. Okay. So this z-score is used to standardize your normal distribution, is used to standardize the normal distribution. Okay. Okay. And so now I write the formula z-score is equal to data point. So data point is your observation, correct?
Yeah.
Our observation, or observed value minus mean divided by standard deviation. So we can put data pointers x. Data point here represents x minus mean represents mu divided by standard deviation psi. Make a note of this.
Yeah. Hello.
Sorry, what did you say?
I said we can move on.
I'm giving you a small example. You calculate the things and tell to me. Come on. I'm keeping the data here. So you are going to find out the Z score for me. I'm not going to assist in any ways. Okay. So far, so good. I understood that you got everything. Just can you calculate the Z score with this? Okay. I'm waiting. So Z score formula is nothing but data point minus mean by standard deviation. Find out this one and this one first.
So for which value should do you want Z score? Hello.
Yeah.
For which value do you want Z score? So you need to give me a data point. No?
That's what. See, this first you find out mean and standard deviation. I'll tell you what to do. These is the data in front of you. This is the entire data. So many students get confused what to do here, how to do this. Very simple. If you find out the mean, what is the mean you got, Abhijit? I'm waiting. Come on, give me the answer.
38.6.
Sorry?
38.6.
38.6. Come on, find out the standard deviation and tell me.
11.83. Oh, it's 11.83. Hello.
Yeah.
So 11.83.
So your standard deviation is 11.8, let's say. So now what is the problem here? Nothing. You take your data point. Let's say your data point is 26. This is the data you have, na? Your mean is 38.6 divided by 11.8 will give you the Z score for this value 26. Z score for 26 you will get. Then in the same way Z score for 33 also you can get. Z score for 65 also you can get. Okay. Just find out for 4 values and tell me, because one interpretation I need to give. What is the value of first one? Hello. What did you get for this, Abhijit?
Wait.
Are you hearing my voice?
I am able to hear you, sir. Are you able to hear me?
Very low pitched voice today, Abhijit. But okay. So what is the value you got?
Should we reconnect or something? Should we reconnect in another day?
No. I think you have put your earphone maybe or something, or you increase your this volume of your laptop. Let's see. Hello.
Is it better now?
No. Maybe you are using earphone.
Yeah, I am, because it won't work without earphones.
Okay, but I'm getting voice in a very low pitched manner. Fine, I'm able to like understand. So what is the value you got for this?
Negative 1.06.
1.06 negative, correct? And for 33 you will get 0.47 negative. 65 you'll get 2.23 positive.
Yes.
And 28 you'll get 0.89. Okay. So now see, Z-score tells us where the data point falls relative to other points. Okay. With respect to 26, where does the 33 where does the data point 33 false, correct? So Z-score will tell you how far away from mean a point is in steps of your standard deviation. That means how many standard deviations you're away from the mean, correct? All these things we understood. What is the interpretation of negative value? It lies in the left side, correct?
Yes, obviously. Yeah.
It lies below the mean and positive one lies above the mean, correct? Now, so we understood what this means. Can you do this question, Abhijit? Do this.
They are getting -2 and -1.
Yeah, so Z score of you got the Z scores now. So one indicates that EPS of $8 is one standard deviation above mean, and this is two standard deviations below the mean because it's negative value, correct? Next. We'll read this and try to do a question.
Okay.
Calculate and interpret probabilities using standard normal distribution. So now we are coming to the probabilities. Okay. So now we will show how to use standardized values, that is Z values. So this will standardize our data and a table of probabilities for Z to determine probabilities. So a portion of table of cumulative distribution function for a standard normal distribution is given in figure 4.5. We'll see that. We will refer to this table as Z table. So that table which is given to us, which is a table which takes cumulative distribution function, okay, is called as Z table. It contains values generated from the cumulative distribution function for standard normal distribution, denoted by f of z. You already know when we use this, we refer to cumulative distribution function, correct? That means it takes all the data, the past data as well, correct? Now,
Yes.
thus the values in Z table are probabilities of observing Z value that is less than a given value. That means probability Z being less than something, okay? this is typical of cumulative distribution function. Correct, Abhijit? Yes. What is probability density probability function? Probability of x taking some specific value x. But if I take x less than x, it is cumulative distribution function. Correct? Hello.
Yes, sir.
Yeah. So, okay, fine. Now let's see this table and what does it say? So in figure 4.5, we can find the probability that standard normal variable will be less than 1.66. Okay. So like f of minus z is 1 minus f of z. This is a formula or property. And in the figure, we can find the probability that a standard normal variable, standard random variable will be less than this, the probability that it will be less than this. For example, table value is 95.15. So the probability less than that will be 1 minus 0.9515, correct? That will be 4.85%, isn't it so?
Yes.
That's what. And which is also will be less than 1.6 is simply 1 minus this, okay? Which is also probability that variable will be greater than 1.66. So this is the like this is one z value or z scores you got, and you already know z scores we were getting 1.65. Okay, here like for 95% confidence interval, here they have got 1.66. So 1.66 is 0.9515, correct? You see from here and here. So this is the probability. Okay. So so less than 1.66, this fine. We have found out this one. Let's move forward. So let's do this question, Abhijit. Considering again EPS distributed with mean $6, standard deviation $2, what is the probability that EPS? So they are asking you the probability. Now we have to find out the probability that EPS will be 9.70 or more. Okay, the probability of EPS being more than this value. For this, first thing is we have to find out the Z score. So like EPS, this is your data point. Am I right, Abhijit?
Yes. Yes.
So data point or observed value minus the mean by the standard deviation gives you Z score 1.85. So like your 1.85 standard deviations above the mean. Why? Because it's a positive value. Now 1.85 will take from that. 1.85. It comes to this 0.9678. So 0.9678. So what we have to do, 1 minus 0.9678 will give the probability of EPS more than 9.70. Correct, Abhijit?
Yes, that is correct.
Yeah, because this is less than probability. 1 minus this, if we remove, we get the more than probability. Correct or wrong? That's what. So you get this. Come on, see this question once, and then we will go for less than. Okay, less than. How to do that less than thing? You'll get. We will do that. First, you have a look through this. Then we'll go for that one.
Yeah, we can do that. Yeah, Hamid, you can go ahead.
Sorry.
You can go ahead.
Yeah. Using so now the same using the distribution of EPS with mu this. You have to see that is less than 4.10. So you get a Z score of negative value, and 0.95 we will see what it is. 0.95. But here we have all more than once. So So this is like for the more, we have the less than ones. So if we have to get that table is not there here, maybe. Some data is given. When you use standard normal probabilities, you have solved the problem in terms of standard deviations from mean. Okay, this is not the data we are looking for. So minus 0.5 is below the mean, correct? So this particular observed value is 0.95 standard deviations below the mean. So now for the Z table for negative values in back of this book. So we have, I think, back side negative values, Z table for negative values. Okay. Do like they give here, na? Yeah. Z table, students tree distribution. Yeah. Yeah, so we have Z table for negative values, correct, Abhijit, here?
Yeah.
So 0.95 is 0.1711, correct? Are you seeing this?
Yes, I'm seeing the same thing.
Yeah. Since we saw that table, we got the value. It is 17.11%, correct? So the probability that the like observed EPS is going to be less than 4.10 is 17.11%, correct?
Okay.
Hello.
Oh, yes, sir.
That's what. That is left side. That will come in the left tail. That's it. If you're done with this, I'll move forward, Abhijit.
Yeah, we can move.
Yeah, have a look through. No problem. Have a look through. Get up.
Yeah, it's fine. We can move.
So what is this Roy's safety first criterion, Abhijit? See, shortfall risk is the probability that a portfolio value return will fall below a particular target value or return over a given time period. That means shortfall risk is you're not making that what you want, correct? There is some shortfall, isn't it so? There is some risk because of which you're not getting the target value or desired return. So this is the probability that your portfolio will give return less than what you expected, okay, or what you have put the target. So Roy's safety first criterion states that the optimal portfolio, if you make an optimal portfolio, minimizes the probability that the return of the portfolio falls below some minimum acceptable level. See, suppose you want 7% minimum returns. So Roy's safety criterion tells you what can be that optimal portfolio which can reduce that probability of you getting returns less than this level, correct? So this minimum acceptable level is called threshold level. So this is my threshold level. Okay. So Roy's safety first criterion, what it does, it minimizes that probability of you of shortfall risk. Let's say it minimizes the probability of shortfall risk. That means your target return if it's not achieving the threshold level. Understood, Abhijit?
Yes.
Okay. That means this is the return from the your threshold level should always be more than this. That is what they say. That means it minimizes. Okay, the portfolio return is like minimizes. So they tell you that the optimal portfolio is that which minimizes the probability that the return of portfolio falls below some minimum acceptable level. So this will minimize the probability that the return of the portfolio should not be less than some acceptable level. That means if you have an acceptable level of this and your portfolio is getting 5, that means this is less than this, there may be some chances for this that has to be minimized as per the Roy safety first criterion, correct? We'll move forward. So maximize the SFR ratio, where SFR ratio is expected return from the portfolio minus the return from the threshold return or level returns divided by standard deviation of portfolio. Okay, so if this ratio is more, the probability of you getting the portfolio return less than the threshold level will be less. Correct? Hello.
Oh, yes, I heard you.
You want a higher ratio. You want a higher Roy safety first criterion. Correct? Now, the reasoning behind the safety first criterion is illustrated in example 4. Assume an investor is choosing between two portfolios. Portfolio A with this return and standard deviation is more here. Portfolio B with this returns and the standard deviation is less here. Investor has stated that he wants to minimize the probability of losing money on negative returns. Assuming that returns are normally distributed, then the portfolio with larger SFR using 0% as threshold return, that means standard normal distribution they're speaking about, will be the one with lower probability of negative return. That means a higher SFR ratio will be minimizing the probability of negative returns, correct? Or will lower the probability of negative returns. So both the things we have, both the data we have to take, and we have to find out the safety first criterion. So expected return, standard deviation, return, standard deviation, we put in the formula, we get the Roy safety first criterion, this, and now what is the conclusion we make here? So panel B of the figure 4.6 relates the SFR ratio to standard normal distribution. Note that the SFR is the number of standard deviations below the mean. Thus, the portfolio with larger SFR has lower probability of returns below the threshold return, which is 0% in our example. Okay, this is what we have put the threshold return, correct? Now, using the Z table for negative values, we can find the probabilities. So we will find out the probabilities, and the probabilities as per these numbers, we will go to the negative Z table 0.0883 and 0.67. Yeah. 0.67. So 25.14%, 0.088 something, na? 0.0, no, 0.88 it was, correct, Abhijit? Hello?
No, 24.1, 25.1.
No, this is the probability. No, another Roy safety first criterion was 0. minus 0.8 something. Can you tell me?
That I don't remember actually, because 25.14 I remember, but the exact
25.14 I got, Abhijit, for minus 0.67. There was one more, another Roy safety number, na?
I don't remember is what I'm trying to say.
I don't get you what you're saying. 0. Okay, I think the number is there now. We'll see that. So 25.14 we got one. Okay, for this 0.88, so 20.33, and you see this the probability here is more than this, correct?
Yes.
So like portfolio, so yeah, so portfolio B has higher SFR. Portfolio B has higher SFR, which means it has lower probability of negative returns, correct? Which one is that? B. This one is the B. Sorry. Yeah. So which one is like 0.883 is the higher SFR?
Which has lower probability of negative.
This is low. Yeah. So portfolio B has higher SFR, which means it has lower probability of negative returns, and The probability was 20.33. This is lower probability of negative interest, correct? So this is the better portfolio, na? Because of which you will be saving yourself from losses. Here the probability of negative returns is high. Here the probability of negative returns is less, because higher the number, less the probability. Lesser the number, higher the probability. Okay, there's a negative relationship. Can you do this question, Abhijit? Here also we have this, and this. So we can see this is the highest number which will have the lowest probability. So the probability of an ending value of A less than this is simply this, which means we can find Z to the probability this 30.85. Okay, we'll see. Abhijit, you do this question. Safety first criteria. So we will see the largest SFR ratio. Largest SFR ratio you're getting for this one only, na Abhijit? Portfolio A.
Yes.
Yeah. So we'll see. You go to this. This is the last question. Do this question. I'm waiting.
Could you okay. What table are they talking about in the?
Sorry.
What table are they talking about?
No, see, you got this SFR ratio, na?
Yes.
Yeah, so find out the SFR ratio. That's it.
That I got.
Yeah, you got, na? So which is the highest SFR ratio? This one. So the probability of an ending value of portfolio A less than this is simply this, which we can find on Z table for name. So probability is 30.85%. Okay. So what is the step they said is calculate the SFR ratio. So we calculated the SFR ratio for all. Then what did they say is no need to go for that probability. Choose the portfolio that has the largest SFR ratio. Correct? So the largest SFR ratio comes to this, and there is a negative relationship. Now, higher the ratio, lower the probability. Correct? Hello?
Yes.
Higher the ratio, less the probability.
Of course, right.
That's it. So with 0.5, so here also, the ratio was higher in this case, and the probability was lesser. The ratio was lower, the probability was higher. That's it. So SFR ratio highest we should take always. Okay. You want me to go for the probabilities or no? That's enough. We'll check for the one. No problem.
No, that's enough. Probability I can calculate. That's not an issue.
Yeah, that is okay. Just to have a look through and we'll close it. However, we are into the last step of this chapter. So tomorrow I'll close this chapter for all. Once for all. So 0.50. This is like the one. 30.85% and 0.4 34.6. So 30. So higher ratio, less probability, and 0.44 was even 33%. So this was the lowest probability, correct, of negative returns. Finished. Okay, Abhijit.
Yeah.
Now the next one is You have to do these questions. We will start from log normal, T distribution, chi-square, and F distributions in the coming class. That is tomorrow. I am going to put a full stop to this chapter. Okay. Then sampling. Okay, Vijit?
Yeah, fine.
Yeah. Tomorrow, what time then?
We'll connect.
I'm calling you, Abhijit. I'm not hearing the voice. I'm calling you.